1, we will push this particular button, then what will happen? Let us have a look to that. Okay. Yeah. So let me use a pen here. Most of you have done a very small mistake here, I can say. Okay. So now see the position of your compressor. This entire box is going to shift to this particular direction. So what is going to happen is your top tappet is going to be like this. This is your end tappet. Okay, I'm just drawing this one. Okay, this will be your circuit. This is going to be your circuit. Okay, most of you have done a mistake here. Okay, now this, since this entire boxes are shifted to this particular position, now this will be connected to your compressor. Let me use a black color for compressor. Okay, now this is going to be connected to your compressor, and this will be your exhaust. Okay, this is going to be your latchet, sorry, tappet. Okay, and this entire DCV has shifted its position, not this particular flow line. Okay, so this particular flow line will be like this only. I'm just repeating this single example for a very single value so that you can understand where you were wrong. Okay, most of you are wrong, so just have a very quick review of this. Okay, now you can see that this entire position has been shifted. This particular red box has been shifted, not the entire you can say position of the entire system has been shifted. Now because of this, okay, now this compressed flow is going to flow. Let me use a green pen for your flow of air. Now your air is going to flow into this particular direction, and this flow line is going to get actuated. Okay, when this flow line is actuated, now you can see that this entire box is going to shift. This entire box is going to shift. Okay, now what will happen? Let me use red color. Yeah, so now actually I don't have mouse with me right now, so drawing is a little bit issue because I'm drawing it through the touchpad, but you can understand it very easily, I think. Okay, this is the same valve that was connected. Okay, most of you have done a mistake here also. Now you can see that your position has been changed. This is converted to black color. Now this is your exhaust. Let me connect it a little bit differently. This is going to be your exhaust. Okay, this is connected to your compressor. And this is again going to be your exhaust. Okay, and this particular case is going to be same. I'm not drawing this particular case fully, but this case is going to be same because I have not activated. I'm taking this situation when this 1 is going to be your 1 and 2 is going to be 0. Okay, so 1, 2, and there is 1, and this is 0, and your output. Your output. Output. Okay. Now you can see just have a very quick review on this. Let me just connect this also. Okay, so now see, this has entirely shifted to this particular position. Okay, and this particular position was that these are connected in the same way. Okay, so this entire box is shifted only, not these particular arrangements. Okay, so these are going to be fixed on their space. This entire box is going to get shifted. Therefore, you can see that. Let me use, yeah, black color pen. Black. Okay, now you can see that this is connected to your output off, to the third line of your output off, and this is going to be connected to your output on. So this is your on and this is your off. So for this condition, now you can see compressed air is going to move from this particular direction and this will move for output on. So your output will be 1 in this particular case. Okay, so this is how the entire system is going to get shifted, rather than this red box is going to get shifted and these positions are going to be fixed. Okay, okay, so most of you have done a mistake that you have also shifted this and you have not connected. What have most of you have done that you have connected this to here and you are just saying that flow is passing through. How can a flow pass through it when it is not passing through the DCV? So your direction of your flow is going to be this, and then this, you can see arrow, this is going to be passing through this particular line. And here also the compressor is providing compressed air, and that compressed air is moving from this position to this particular position. Okay, I'm going to keep this particular answer. Okay, is there any doubt? Most of you have done it in a incorrect manner, so therefore I had to repeat this particular answer. This box is going to get shifted. Yeah. Okay.
Sir,
Yes, Bhanu.
sir, this middle line is this for partition that is adjacent to the T?
Yes, this is for partition for both the blocks. See, this is just a very simple case of logic. Let me tell you. Let me just zoom it a little bit and tell it to you that this logic is changing. Okay, so if we are taking this particular example only, okay, for this particular valve only, then let us see that what the example is going to, how this particular example is going to change. Just for this particular part, okay, I am going to focus on this part only. This particular part only. Okay. So let me use a black color pen here. Black color pen, and let me draw this particular valve. There is a partition and this was a 5x2 valve. Bhanu, am I correct? Kindly
Yes, sir,
unmute
5
your...
by 2. Yes, sir.
Yes. So there will be two positions.
Yes, sir. Two positions.
Okay. This is not a 5x2. This is 4 ports. 1, 2, 3, 4. Am I correct or not? What kind of ports are these? These are 3 ports only. Rather, only 3 ports are there.
If
See,
I'm talking about positions, only 2 positions and port.
3 ports. See, 1 port, 1 port, 2 port, and 3 port. Only 3 ports are there for single position.
Yes, sir.
Am I correct or not? Here you
Yes.
can see 1 port, 2 port, and 3 port. Just from looking into the diagram, you can interpret whether your what is the type of your what we say. What is the type of your directional control valve, which is your DCV? What is the kind of your valve? So this is a 3 port and 2 position valve. Bhanu, am I
Yes.
correct?
Yes, sir.
Yes. Now there are 2 positions which are being partitioned by this. Okay. So either for one position, it can move from this direction and can stop. Okay. Or what it can do, it can move from this particular direction and it can get reversed back. Okay. Now you can see for this particular position, we are just taking this particular position for first case. Your compressor is here, which is where the flow is being stopped by a tappet. You can say there is a stopper which is disconnecting this compressed air to the system. Okay. And this is your exhaust. Okay. This is your exhaust. So what, and this is your pneumatic controlled line. Okay, this is a pneumatic control line. Now you can see that there are 2 positions here. First position will be this, second position is this, or you can say this is the first position and this will be the second position. So let us consider that this is your position number 1. Okay, for this particular case, you can see that air is not flowing from the compressor. Rather, what we are looking here is that air can be exhausted from this particular valve. Okay, because this is the exhaust, so air might be coming from this particular direction and it will be exhausted from this particular path to the exhaust. Okay, this is your first case and this is for your first position for a single valve. Okay, for a single valve. Okay, now what will happen when I will push this particular button? This position is going to be relatively changed. Okay, now how this particular position is going to be relatively changed, let us have a look to that. Okay, let me erase this, and this, and this, and this, and also this green color arrow line. Okay, this is fixed, but only the position of your, what we say, yeah, position of your valve is going to be changed. That's only. Okay, and let me just remove this also. Let me use an eraser and just erase this also. Okay, so this relative position is not changed. What has been changed is your position of your DCV. So the position of your DCV is changed. Have kindly focus on this, that now your position of the DCV is changed. So for this particular example, this entire DCV positions are shifted. Now, previously this logic was this, which has been shifted to this particular position. And now when it is shifted to this particular position, it is shifted like this. Okay, now you can see what will be the flow now. Now it has got the path, your compressor has got the path, and your flow is going to move to this particular direction. And since it is pneumatically actuated, this is going to shift. So this is the partition between the 2 positions. This is the partition between the 2 positions. So this is your first position, this is your second position.
Yes, sir. Now it's clear.
It is clear. Okay. Okay.
Thank you.
So is it clear to all of you now? Class, kindly respond on the chat box. Is it clear to all of you now? Yes. Okay. 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 So today we are going to link. Okay. So you had a session of industry expert who taught you about the what we say system simulation. Okay. But you were not very much comfortable with that because that was a very high end software, and the you can say the fundamentals associated to it were not very much clear to you. But if we are going to see that how we are integrating a system, how we are infusing or integrating electronics into a particular system, for that again we are going to use the same methodology of teaching that I am using in these particular sessions. We are going to understand it through videos. I am going to give you that videos. I earlier also told you about Mr. Hegemul, who was an employee of Siemens, and he left Siemens and teaching the concepts of Siemens, all the kind of technologies that Siemens deal with, uh, like a freelancer, and his videos are very good. I would really recommend you to follow him, Mr. Hegerwood. And today we are going to just look at the videos of Mr. Hegermul, that how he is interpreting or how he is making you understand what is pneumatics, and how you can associate it with your electronics. So I have told you about the pneumatic control. Okay, and his series of videos is showing that how you can connect with or switch from pneumatic control to electro-pneumatic control, or how you can infuse electronics into pneumatic. Okay, so a very interesting session again, students. Just have a brief look. If you have any doubt, I am here. I will explain you each and everything, and we will not move forward until and unless you know how to integrate pneumatics with electro-pneumatics. Okay, so
Okay, so today we will learn a little bit about pneumatics, and we'll be using a software.
So he is Mr. Hegerman,
Fluid Sim for that.
And he is using Fluid Sim. Okay, so I'm just writing this on the chat box. If you are interested, I don't find any reason for you to use this particular software. Your only motive is to understand that how you can connect what we say pneumatics with electronics. Okay, and Fluid Sim can do that in order to make you understand. If you want to install this particular software, I will provide you the link where you can do that, and if you have any doubt, you can do it on your own. Okay, but I don't recommend you to do that. You just need to understand that how a pneumatic process is working, and just in order to make you compatible with the pneumatic diagram and pneumatic integration. Okay, so if you want, you can connect to me. I will give you the link on the WhatsApp group. Okay, and if you have any doubt, you can anytime connect with me. Okay, but if you are interested, then you can go ahead. I can also take a session on this. Okay, but just have a look on the Festo Fluid Sim software, so that you can understand the connection between how pneumatics work internally and how you can connect it with electric control. Okay, just have a brief view. So is the sound of video and the video quality good, class? Was the sound good and video quality was good? Yeah, okay.
Nice, relaxing, focusing music, copyright free, of course. So here we go. That's good. first of all, we want to learn something about actuators. I am using here the FluidSim version 5.5. Could be that you have some other version and that your library here on the left doesn't look the same, or your field, or some of the icons here on the top, but that's what it is. You can still find most of those things on the left here. Even the older versions were already quite good. So let's have a look at a single acting cylinder and a double acting cylinder. You can see my field here is quite big. So let's zoom in a bit. Single acting, double acting cylinder, different purposes of using those. But in this session, we don't want to learn why we use those. We just want to learn how we use them. The main difference between those two is that the single acting cylinder here on the left has only, oh, the music is actually a little too loud for me here. The single acting cylinder here on the left has only one inlet. If we put a high pressure on that inlet, the cylinder will extend, acting against the spring force, releasing the air directly at the cylinder. If we have a lower pressure than the atmospheric pressure here, plus the spring force, the cylinder will retract. That's as simple as it is. You blow in that hole, the cylinder will extend. You don't blow in that hole anymore, the cylinder will retract. That's as simple as it is. And this is also what we will do here in the beginning. A compressed air supply. You see my software version directly connected to the cylinder. In contrast to the double acting cylinder here, let's put it simple, let's not go into details here. If I blow in that hole and release air through this, cylinder will extend. If we blow air in here and release air through the other, cylinder will retract. So if I simply put it's too loud for me, an air inlet on the beginning of both cylinders, I know that I have an open connection. I can start the simulation. And you see both cylinders will extend. At this point, I cannot retract any of those cylinders. That's what we have. They're both there. Always blowing in the first hole here. So what I can do with the double acting cylinder is I can put that source on the other side and the cylinder will retract instead. Right? I cannot do that with the single acting cylinder because I do not have the air connection here anymore. It will automatically retract. So that's the difference. This one here retracts automatically. This one here only retracts if you put in air, pressurized air from the other side. So our goal is to also control the air. Right? We want to control the airflow with a button with a switch, so-called directional valves. Directional valves come in many, many different shapes. The general rule of thumb is to use a 3/2, 3 meaning 3 connectors, 1, 2, 3. 2 means 2 switching positions, 3/2 way directional valve. Ooh, there we go, difficult. For a single acting cylinder, and we connect the working port to it. The exhaust port 3, I can double click on it and I can put an air outlet directly here, in the best case with a silencer. And at port number 1.
So class, this is simply an exhaust. Rather than exhaust, in pneumatics we used a particular silencer, which is, you can say, made by powder metallurgy, a very common brass material silencer. So what it does is that during exhaust, if you are directly providing the atmosphere to the exhaust air, then there will be a lot of sound. Okay, so we use a particular kind of you can say silencer, which I will also show you here. Okay, and you will come here, or I will also show it in the slide. This is just a kind of exhaust. So this is just going to be exhausted from the system.
I will have my air inlet, my pressurized source. So much for a single acting cylinder has one inlet. That's why we only have one output for our switch. If I have now a double acting cylinder, I have 2 inlets, so I will also need a DCV, so-called directional control valve, for the double acting cylinder with 2 outputs. Right? This one has two outputs. They need to be connected to the cylinder itself. Then we have three inlets, meaning one inlet and two outlets here. One inlet and two exhausts. The exhausts will get the silencer here again. Let's use those big ones. They don't look pretty at all. Let's use the smaller ones. Exhaust mufflers so that the sound isn't too strong. And the supply port. We just need a double-acting cylinder needs two inputs, two inlets, has two inlets, so we need two sources we can control. That's as simple as it is. And this is the difference between in control between those two.
Yeah, so class, just a minute. Okay, so just tell me that this is the what type of valve is this? Kindly respond on the chat box. This particular valve is of the type. Three by two DCB. Yes, correct. 3x2 DCB. Yes, correct. Sahil, Raj, Muskan, Bhanu, Nayan. Yeah, yes, correct. And what is this is the type of which kind of valve? This is 5x2. Yes, correct, Muskan. This is 5x2. 5 ports. You can see 1, 2, 3. There are 3 ports. 1, 2, 3, 4, and this 5. There are 5 ports. You can see the connections also. Connected to 1, 2, 3, 4, 5. And this is connected to 1, 2, and 3. Okay. This cylinder is single acting or double acting? This particular cylinder, is it single acting or double acting? Single acting. Yeah. And this particular cylinder is single acting or double acting? Yeah, double acting. Yes. Now, and these are your exhausts. Okay, or you can say silencers.
So let's have a look. If I press start, I can right now see the difference for a double-acting cylinder. The air goes into the...
So you can see the darker side is for high pressure inlet. Okay, and you can see this light blue side is for exhaust. Okay, now you can see that this is high pressure line coming from compressor. This is the high pressure line coming from compressor, and it is switching its particular direction, and high pressure line is moving to this particular part. And from here, obviously that particular air, when it is moving from this position to this position, this line will be exhausted to your exhaust. Okay, and here because of spring, your air has been exhausted to this particular side. Okay, just take a screenshot of this solution. Yeah.
Retract port. This is called the retract port. Big blue line means high pressure. So the air goes into the retract port, and air can go out through the extension port here. So this is the flow we have right now. Here, for the single acting cylinder, we do not have air directly coming in here. We have air, the ambient air, which is 1 bar approximately, coming in here. So this is basically ambient air right now, pressure coming in here. But we have the spring force acting, so the cylinder will retract. The spring force is pretty much, it is similar than as the air going here into the retraction port. They have the same purpose. That's it. But in contrast to the double-acting cylinder, I do not especially need to connect a DCB here. or another air source because it used the ambient air. So if I switch over, if I click on the DCV here, I can switch it over. You can see air will go through the DCV into the extension port, and the cylinder will extend, acting against the air pressure ambient air from the outside, plus the spring force. So that's pretty simple for a single acting cylinder. For a double acting cylinder, if I do that, air will now go from the supply to the extension port. This is the same as in the single acting cylinder. And then air will go through the extension port, through the exhaust through the DCV to the ambient air. We need that so in case we want to go back, we can switch over both ports. We're always switching both ports. That's the difference here between the single acting cylinder and the double acting cylinder. So far, so good. We have some more components that we could use right now for both cylinders. We have so-called control valves, more types of control valves. And we will need some space here in between because we want to control something. Here, at first, let's control the speed because those are pretty fast. See? Something here. At first, let's control the speed because those are pretty fast. You see, only limited right now by the air pressure and flow rate because we want to control something. Here, at first, let's control the speed.
So you can see that in this particular case, now when you are switching the lines, okay, when you are switching this particular DCV direction, okay, when you are switching this particular DCV direction, you can see that for this particular condition, your flow is moving from this particular direction. This is just for a single.
Because those are.
Yeah. And when switch it, high pressure line move from this particular direction to this particular direction. And it is pretty fast. So in order to control this, we will need, can't we use a single exhaust with dual connection? Ritik, I didn't understand your question. Can you please elaborate your question? Can't we use a single exhaust?
सर मतलब जैसे अभी जो डबल एक्टिंग सिलेंडर है इसमें 2 एग्जॉस्ट यूज हो रहे हैं हमारे.
ओके, हाँ, हमारे 2 एग्जॉस्ट यूज हो रहे हैं. ठीक है
सर, स्टार्टिंग में इनिशियली एयर 1 से 2 में जाएगी और 4 से वापस आएगी.
1 से 2 में गई और 4 से एग्जॉस्ट होकर के सीधे एग्जॉस्ट पोर्ट पे चली जाएगी. हाँ, करेक्ट.
सर, अगर मैं इस 4 वाले पॉइंट को सीधा डायरेक्टली 3 से कनेक्ट कर दूं,
4 को आप 3 से कनेक्ट करोगे, ठीक है, तो आप जब दोबारा स्विचिंग कर दोगे इसको,
हाँ, और वहां पे जो दूसरा वाला पॉइंट होगा फिर उस टाइम पे वो 2 वाला पॉइंट इससे कनेक्ट हो जाएगा 3 से.
नहीं, आप देखिए, अगर आप इसको कनेक्शन, आप मेरे को ना एक फोटोग्राफ भेजिएगा उसके सोल्यूशन का, फिर हम डिटेल में देखेंगे उसको, क्योंकि वो फिजिकली पॉसिबल भी होना चाहिए ना. अंदर पोर्ट का कनेक्शन तो हमने देखा था ना फिजिकली. अगर आप पोर्ट को क्रॉस कर दोगे किसी भी तरीके से तो वो भी तो ठीक नहीं है ना.
पोर्ट को क्रॉस करके अगर मतलब डबल कनेक्शंस बन जाए वहां पे.
आप ये कह रहे हो कि हम 2 एग्जॉस्ट पोर्ट क्यों यूज कर रहे हैं, एक ही सिंगल एग्जॉस्ट पोर्ट क्यों नहीं यूज कर रहे, ताकि एग्जॉस्ट एक सिंगल पोर्ट में चला जाए. हाँ, वो कॉमन लाइन बना करके हम कर तो सकते हैं, बट लेट अस सी कि उसका सोल्यूशन कैसा होगा. अभी फिलहाल इस केस में आप देखें तो एग्जॉस्ट केवल एक ही यूज हो रहा है हर सिंगल केस में.
एक टाइम पे तो सर एक यूज हो रहा है इसमें. तो हाँ,
इसमें हमेशा एक ही यूज होगा. ऐसा नहीं है कि 2 पोर्ट्स में एग्जॉस्ट हो रहा है. एक एग्जॉस्ट बंद होगा, एक एग्जॉस्ट खुला होगा. ठीक है ना. आपका सोल्यूशन हो सकता है पॉसिबल हो, देयर माइट बी अ सोल्यूशन. ठीक है, मैं अभी इस स्टेज पे तो नहीं बता सकता जब तक मैं उसको पूरी तरीके से, बट देयर विल बी सम प्रोज एंड कॉन्स फॉर दैट आल्सो. ठीक है ना, हम उस पर डिस्कस करेंगे अच्छे से. पॉसिबल तो हो सकता है. आप ये कह रहे हो कि ये यहाँ से हटा करके, मतलब 3 को हटा करके, अभी अगर इस केस में देखें, या 5 को हटा करके आप 4 से डायरेक्ट 3 पोर्ट में क्यों नहीं कनेक्ट कर देते. ठीक है ना, यही कह रहे हो ना ऋतिका?
यस सर.
और फिर जब ये स्विच होगा, जब वापस स्विच
2 से 3 में आ ही जाएगी वहां से. अगर
2 से 3 में आ जाएगा, और ये जो 4 लाइन है, वो 4 लाइन आपकी जो कनेक्ट हुई है लेकिन ये 4 लाइन आपकी थर्ड पोर्ट पे जाकर के कनेक्ट हुई है। उस केस में तो ये जो कनेक्शन है ये यहाँ से 1 2 जो थर्ड पोजीशन है उससे तो सेकंड पोजीशन पे आएगा, वो तो कंप्रेसर से लिंक हो जाएगा ना फिर। ये जो कनेक्शन है आप ये कह रहे हो कि अगर इसको थर्ड से आपने लिंक कर दिया तो जब ये स्विच होगा तो ये वाला पोर्ट काम करेगा ना,
यस सर, ओके ओके।
फिर इस वाली स्टेज पे काम नहीं करेगा ना, क्योंकि स्विचिंग तो होनी है ना। तो ये वाला पोर्ट सेकंड पोर्ट फिर फिजिबल नहीं होगा। तो इट कैन बी अ सोल्यूशन। आप सोच सकते हैं किसी भी तरीके से सोल्यूशन दे सकते हैं। अभी तक हम कोई ऑप्टिमम सोल्यूशन पे नहीं आए, कभी भी कोई सोल्यूशन ऑप्टिमम नहीं होता, हमेशा चांस होता है उसको अच्छा करने का। हाँ, एक कंडीशन हो सकती है जहाँ पे आप 2 पोर्ट को ना यूज करके सिंगल पोर्ट को यूज कर सकते हो। इट इज अ वेरी गुड पॉसिबिलिटी, लेकिन उसको रिप्रेजेंट कैसे करेंगे और उसको बनाएंगे कैसे, दैट इज अप टू यू। ठीक है ऋतिक?
ओके सर।
Oh, my mistake. Sorry. So my question is, yeah, okay. So just to get ourselves aligned from the previous lecture, my question to you is that when the flow is from 1 to 2, then the flow is restricted or unrestricted? When the flow is from 1 to 2, okay, yeah, it will be throttled or restricted. Okay, okay, okay. Okay, correct. And from 2 to 1, if the flow is from 2 to 1, then unrestricted. Yeah, correct.
Sir, mic off है
Yeah. आप में से कोई अनम्यूट करके बता देना आप ठीक है.
But now nothing will happen because I can still adjust this. But one can already see if air goes
आप ठीक है.
Yes, sir.
in, the little ball is here kept in position, so the air can't go this way. Let's see what will happen. Right now, nothing will happen because I can still adjust this. But one can already see if air goes in, the little ball is here kept in position, so the air can't go this way, it has to go through here. If the air comes back, the little ball is pushed away. This little ball is called a check valve, by the way, and can go out. So this is not throttled in that way. I can adjust the opening level here, which is really an opening level. Let's put it to 5. And this should limit the speed in the ingoing way. We can clearly see that. If I even turn it, let's say 2%. Yeah, that's a smooth behavior. I can only control it in one way. Right? This is a one-way flow control valve. That's good for the single acting cylinder here. Let's see for the double acting cylinder. If I want to control the extension as I have it here, it is always the best practice to control the air going out of the cylinder. Not going into detail right now. This has to do with pressure build up and flow, but it's always better to control the air going out. So if we put this one also to 5%, because it has a more linear behavior, whatever that means. Let's see. This is a smooth behavior. Extension and retraction is unthrottled. If I also want to throttle the air going out, I also want to control the air going out. Here we go. Here we go. So both directions I can now control. I want this a little bit faster. Here we go. Right. This is how I can control the speed. This is how I can control the speed. If I now, next thing, so let's go for one more in this little topic here. Next, I don't know if the simulation will actually do that, but if we have, that's what we usually have, is very long lines, right? Very long lines, and they need to build up some pressure. Let's make that even longer here. Very, very long lines. And you need to fill those lines with air first, so the air cannot directly go out of the system, so this is slowing down already quite a lot. So right here, when the cylinder is extending, all of this line has to be filled with air. That's pretty stupid, right? That's not what you want. So you're actually not going as fast as you can, as you possibly could. Oh, this is too far away. I don't know if the simulation will do that right now. Yeah, it's still pretty fast. But in reality, those lines can be 100 meters long, so you have a lot of pressure built up. So what you want to do is you don't want to have the airflow through all the line. You want the air going out directly at the cylinder to have the maximum speed. So what we can use for this is called a quick exhaust valve. A quick exhaust valve, those ones here, will let the air out directly here at the cylinder. You see the exhaust here? If the cylinder extends, air will go out directly through the exhaust here. We don't have to go all the way back. That's the advantage of this. So right now the extension is at maximum speed possible, right? Because the air goes out directly here. It's pretty hard to see, but you see the little ball. Right now in extension state, air can flow this way. The ball is blocking this way, but air can flow this way. If you're retracting, air can still follow the line. And this is how you can build very simple.
So what he has done is he has not changed anything. Just he has used this particular valve. Okay, and this particular valve, in order to reduce the length, not to reduce the length, in order to sustain to a particular system where the length of the pneumatic system is very large, we can use this kind of system where exhaust can be done very near to the component or an actuator, which is your double acting cylinder in this particular case. Okay, so we can place this particular exhaust type of valve system. So when pressure is applied, okay, when pressure is applied to this particular side, this ball will move to this particular side and it can retract this particular cylinder. But when it extends the exhaust, okay, so exhaust can be directly, and the air in this portion can be exhausted directly to this exhaust, rather than to this particular exhaust. Okay, this can work. This is just a very short trick to accompany the large, or you can say a very long kind of pneumatic system. That's it. But the main concept is, I think, clear, that how a double acting cylinder and a single acting cylinder works through 3x2 valve and 5x2 valve also. So class, is it clear till now? Is there any doubt till now? Yeah, okay, I think this is simple. Yeah. So now let us move to logic circuit. How we are going to make a particular logic circuit.
Welcome back. Next video on pneumatics. Let me put on our learning music here again. And last time we built our simple logic circuits here with a single acting cylinder, double acting cylinder, one-way flow control valves, the DCVs, our quick exhaust valve, and our little compressed air supply. It's not a compressor itself, it's just a compressed air supply. Wherever that comes from, it could be that someone is blowing into the line. Now I want to have a look at those things here, right? But now they're behaving like this. Like if we would have them in reality like this, the DCVs, directional control valves, they would be doing the following. That's it, they don't do anything because they do not have an actuation. We can put an actuation on any of those sides. One of the standard types, if I double click, depending on the version, you can do that or you can do that. Depends on the fluid sim, but this is just about the pneumatics, so you don't even need fluid sim for that. So this one on the left here, for the double acting cylinder, for the single acting cylinder, I want to control on one side. I want it to be spring returned. So we can see the little icon of the DCV here. And now it's spring return. Spring return means the following. Let's start the simulation now. I click it, and if I release it, it will automatically return. Only click once, right? As long as I keep it pressed, it will be activated. If I release it, it will come back. So that's good. And that's good. Spring return. This is good. I could theoretically, you could get one of those with the spring on both sides, which doesn't make much sense. In special cases, you might need one, but nah, usually not. On the other side here, let's see, I want to put, for example, a simple push button. A push button, that's the most simple setup. And this now is, in reality, this reflects a real push button, like that you press, right? Push button that you press. That's good, we can have that. Another one we can have is, for example, this one, which is the latching push button, a push button with a latch. Could also call it a switch. I press it once, it stays in position, and then I can release it with the next click, like a switch or a latching push button. So there are many different activation types, right? Many different activation types. Let's keep it with the push button for now. And with spring return on the other side here. Right? I could do the same with the second valve, with the second DCV of the DCV for our double acting cylinder. I could, for example, put a push button on both sides here. Right? A push button on both sides. That's good. That's good. That's good. That's good. That's the most simple setup. Right? That's the most simple setup. What we could have, what is usually done, right, is not something like this where you have a push button only. Sometimes you might want to have some activation type, right? Some type of activation that is not manually. If you want to have a logic circuit, for example, an OR or an AND, some logic circuit, you will need something to do that. So that's something it would be called here, if we want to have a purely pneumatic control here. Pneumatic controls, right? Pneumatic controls. And now I could build some logic circuit in before if I'm looking at pure pneumatics. What we could also have, so I will get back to that in a minute. What we could also have is the following: can have mechanical switches, mechanical things, right? Which is simply said sensors. I can have sensors, different types of sensors. For example, here this one is a magnetic proximity switch. Magnetic proximity switch. And I have to give that one a name. A name means identification, so that my software here knows, this here is called 1M1. So everything that is called 1M1 is connected to this one.
So class, we have seen in these examples that we can also, what we can do is that we can control the positioning of these valves. Okay, so we can control it mechanically, we can control it through spring return. Okay, we can also convert it, you can say control it through a switch, or you can say a magnetic reed switch in this particular case. This is a particular sensor which once it is sensed, when it is sensed, then what is happening, that this sense is going to switch the direction. Yeah, class is done. Yeah, so class, let us continue with the video.
Let's build a simple circuit here. I have my other cylinder. This cylinder, I have something called actuating labels. Actuating labels are sensors. Like if the cylinder is in position 45 to 50, because it has a hoop, an extension rate. I forgot the word in English. I only know it in German. Has an extension of 0 to 50 millimeters, and I only want the sensor to activate from 45 to 50. I will call that, of course, 1M1, right? 1M1 is now, you can also see it actually here. Those two are right now connected. So if I activate now my DCB here on the left side, I will have air flowing into the cylinder through the one-way flow control valve. And the cylinder at some point will activate the sensor. The sensor will activate the DCV for our double-acting cylinder, extending the double-acting cylinder. So let's see. And we see it takes a bit of time. Oops. It takes a bit of time until my cylinder is extended, and as soon as it reaches the sensor, my double-acting cylinder extends. Right? Some sensor circuit. That's good. Let's keep that. Now I want this cylinder should only extend if this cylinder, that's a clamp, for example, for safety, or that's a gate, some safety gate closing. And only if the gate is closed, like only if this sensor is active, this cylinder should be able to extend, right? So we need some AND circuit here. Only then, and I need to press a push button. Gate closes, I press a push button, cylinder extends. So here I also need the push button, meaning I have to build an AND circuit. And to build such circuits, let's see, I have to configure my valve back here, and I will give it the pneumatic actuation, right? The pneumatic actuation, and I will put, I will need more DCVs for this, right? DCVs, and right now I only want to control one input here, so I will take 3-way DCVs, right? 3/2 DCVs, 3/2. They will both get and source, a pressure source, and they will use the same here. And they will all both, of course, have exhaust. Here we go. And you will also get one. And now we would need to connect them here in some kind of OR fashion, AND fashion. I could put them in series, right? I could put them in series like this, right? But that's bad design. If it comes to more complex circuits, you will get lost with this. That's why you don't put them in a series. You have special components. You have a pneumatic AND and you have a pneumatic OR that can help you with this. A pneumatic.
Okay, class. We have looked at the AND circuit also. Now you understand that when these walls are in series, then the logic that can be operated is AND or OR. Can you tell me, class, when this? Yes, the logic will be AND. Yes, this logic will be AND. Okay, but it is not recommended in pneumatics also that you put two walls in series. Okay, so for that we have a very special kind of switch, and it is represented
AND because we want this cylinder only to extend if we press a push button. So let's make this a push button, right, with spring return. Whoops, I pressed on cancel. Sorry for that. Push button with spring return. Right? That's my first. And I want this one to be a spring return with the sensor there on top, which I will call 1 and 1. Right? And they're going into this component. And this component, which is a dual pressure valve or a two pressure valve, or simply said a pneumatic AND. Right? This is a pneumatic AND. So if I connect both sides here and the output to my cylinder here, let's observe what's going to happen. I activate my cylinder here. The sensor will activate. With the sensor activated, the DCV here will switch positions. This is what we can see now in the first step. If I press shift, this one will stay active. Or let's put it actually easier. I don't want to press shift, so I can have this a latching or a latching button or a switch. If I press it, activate it, and you saw as soon as the sensor here is reached in the end, we have this DCV switching over.
Again, we can see that this 1M is kind of a sensor which just senses the position of this particular piston. And we have seen that how we can position it accordingly into the software. Just when the piston reaches to the defined position, this sensor is going to activate or actuate from this particular side. Okay. So in our pneumatic cylinder, what kind of sensor we had? We had an example in while making our energy, mass and information flow diagram. We had a proximity. Yes, it was a proximity, but what kind of switch that was? I had also shown you a particular video of that particular switch. What kind of sensor? Yes, magnetic reed switch. Yes, very correct, Ritik, very correct, man. Okay, so in pneumatical operations, mostly that magnetic reed switch is only used. Yes, correct, Alok.
And the AND, because it's an AND block, is blocking the air going in here. We also need air of a similar pressure, almost the same or similar pressure on the other side here. And then air can flow to here and the DCV will switch over and our cylinder can extend. That's the flow here. So let's see. It was a little bit fast. If I want to make that slower again, and now I want to make it slower in both directions, so that was not too smart. I want to make it slower in both directions, so I have the one-way flow control valve in both directions and an opening level of, let's say, 2 and 2 as well. Let's see this again. I press the button, cylinder will extend, 1 and 1 will activate, 1 and 1 will activate and press the DCV here, and our end will have the first input, and then I press the button, we'll have the second input, this DCV will activate, and our cylinder will extend. I can also press the push button here. Nothing happens yet because we need the sensor. Let's get the sensor first. Sensor activates, push button. And now I see I need to keep it activated, right? Keep it activated. I still press it, cylinder extends. It's in the end here, and now has to go back. Right? That's what we have. If we have an end circuit, we could also have an OR, which is a shuttle valve, right? Which is a shuttle valve. It's 2 check valves somehow connected. And now I want to have the following. This cylinder will extend if I press a button or if the other cylinder is extended. Right? That's an OR circuit, so I can just replace my DCV here, my 2 pressure valve, and now I have an OR circuit. If I press the button, it will extend. That's a very slow pressure build up there, that's okay. Or if the other cylinder, right? Now I can press both, doesn't matter. So also, what we should consider now is a little bit about safety. Right now we are separating this into 2 circuits, into a power circuit, everything that I select here up here right now, and into a logic circuit or into a control circuit. The control circuit is usually where you press buttons, and this one should be more safe, like in electricity.
So class, now you can understand that yes, we can create a logic through pneumatic circuit also. Okay, so what kind of logic have we created through pneumatic circuit in this particular example? And okay, and have we created OR? Yeah, and OR both. Yes, we have created and OR logic, a very simple and OR logic, simply through pneumatics also. But is pneumatic creating a particular logic through pneumatic recommended in industries at this point of time? Yes or no, class? This question is for all the students. I need answers from all the students. No. Yes. This kind of switching is not allowed. Then what is the solution to this? PLC. Yeah, electrical switching was one of the solution, and now it has been shifted to PLC. Yes, correct. Electronics is the solution to that. And in industries, there are going to be pneumatic solutions, or most of the processes are actuated to pneumatics only. And if there are any other process also, then also the kind of flow is same. So once you understand pneumatics, you know half of the about any process.
This is all high power, 230 volts, 16 amps, something like this. And this is low power, 5 volts, 200 milliamps, something like this. This is safe to do whatever you want with it, pretty much, not everything, but pretty much. And this is dangerous. So this here, I want to have a lower pressure, right? A lower pressure. I can click on the pressure source and I can change the operating pressure, right? If I press start, I can actually see that. I can change the operating pressure and you can see the line is getting thinner and thinner, right? So we need a lower operating pressure. And you can see a light blue line. A light blue line should be fine here for us. Should be fine to activate our logic circuit because we do not need that much pressure in the logic circuit here. Could be dangerous. What we would have in reality, of course, is the following. We would not have 3 different pressure sources. We would only have 1 pressure source. And we would only have 1 pressure source, I know. And this would be somehow connected to everything, right? And therefore we will need some service units, which is this strange icon here. At a service unit, you can select the pressure. This is a pressure regulator. You can see the pressure and you can have a filter. There's a more simple icon for that, this one. Right? That's the same. That's the same as the one I just showed. It does the same 3 things. And we would have.
So students, we have learned in previous videos that what is air service. So air service requires 3 operations, and they are: before entering into a system, we need air to be of good quality. Okay. So what are the qualities that the air should have? What are the things that are needed to be checked? As far as, yes, it should be filtered. There should be no moisture in that. Very correct. And the pressure should have been regulated. Yes, regulated. Okay, so air should have been filtered. There should be no moisture. It should have been regulated. Okay, so there is a dedicated FRL unit for that. Filtration, regulation, and lubrication. Okay, so air also needed to be a little bit lubricated through lubrication oil, so that in many components there is no friction inside, and rather than from applying separately a particular grease to a mechanical component, lubrication can be provided through air also. Okay, yeah, very correct. Ritik, Adarsh, and Nayan, very correct. And Bhanu also. So this is the example of your air service unit, which is some kind of FRL unit, you can say. Okay. Now what he is trying to do is, we never have in industries, we will have separate compressor or air supply unit for different components. Okay. So what in industries we have a constant pressure supply line, and from that supply line there is the supply of compressed air, and that has been connected to each and every component individually. We don't have separate compressor for each and every component. Okay, so this is why he is asking for this kind of solution. And just let us have a look to this also.
Have this to create different circuits, different pressures that we need. Right? We have our compressor, goes in here, goes in there, if I could hit, and also goes in there. And with this, we can control the pressure of each circuit individually now. Right? This one has let's say 2 amps, 2 megapascal. No, I like bar more. Sorry, I was always talking about bar and it was set to Pascal. Let's have this, and I want something like 8 bar. 8 bar is good. 20 bar, let's go. Really fat line over there, 20 bar. This is all set to millipascal. I'm just more used to bar, actually. Let's say this one I want 2 bar, that should be enough. This one should be, yeah, I would have to adjust the whole setup here, how the software. I just installed it today on this machine. It's still messed up, sorry for that. This one should be 6 bar because I need a lot of pressure, and this one can be 4 bar because I don't need that much pressure. And there we go. Now I've got this set up, and all the circuits will still work, right? With our service units and with different pressures, which is now safe for the operator here, right? This is where the operator is. Right now it looks like it's in the center, but it could be meters or even miles apart. So far, so good. now we've learned a little bit about the pneumatic setup here, a little bit about the sensor up there, and so on and so on. The next session will be a little bit bigger. We will be talking about electropneumatics. So we will put some more intelligence in here. Could add a PLC or a microcontroller or some type of other controller. But we will do that without any type of controller, which is the most cheap option we have and actually is still used broadly in the industry. So thank you for watching. If you've got any questions, put them down below. If you like the video, hit like. So welcome back. I already put on our
So class, is there any doubt till now, class? Is there any doubt till now? No. I need answer from everyone for this particular question. Okay. So I think this is an interesting part, and the way he is making us understand that how these things work is very good. And one more question to you is that do you want to practice on fluid sim? Do you want to practice on fluid sim? Do you want to have a session for fluid sim separately? Yes or no? If you want, I can take. There is no issue in that. There is a student version available, and the issue for that is that it only works for 30 minutes. So you need to wrap up all the components in 30 minutes. So do you want a separate session for this, or this video will work for you? This is just for your understanding only. Therefore, I would recommend to skip that part to do it from your own. Yeah, okay. Varun says no about it. And Ankush says no. I need more answers. That do you want to work on fluid sim on your own? You want a separate session, or you want to continue with videos? Yeah. Okay. We'll continue with videos only then. Okay.
learning music here. I saw it wasn't too loud in the last video, so I turned it up a little bit for you right now. I hope that doesn't annoy you. I'll also make it louder for me. Last time we played around a little bit with the pneumatics here in the center, right? So we added a lot of components, and what I want to do now is to have a little logic sequence, not a sequence, but some logics in here. Cylinder 1 extends, cylinder 2 extends, or I press the button to cylinder 2 extends, right? So some logic in there, and now we want to step our game up to the next level, and I don't want to have a pneumatic control here, right? I don't want to have a pneumatic control, and let's make this simple. I don't want this anymore. I don't want this anymore. I'm just making it a little more simple for me right now. So we have the, oh, this could be too loud. I don't know. I feel, yeah, that's good. That's good. So now we have the cylinders and our setup like this, and I want to control our little circuit here. Our little circuit, I don't want to control manually anymore. I want to control it with something called electricity. And this thing here that I just added is called a solenoid. A solenoid, and this whole thing is now a solenoid valve. And I'll do the same for our second valve here, which will get a solenoid on both sides. The difference here is now the first cylinder will extend as long as this one here has current flowing through it. The second cylinder, I don't want the return string there, whoops. The second cylinder here will extend if there is anything on this, if there's current flowing through this solenoid, and we'll recheck if current is flowing through this solenoid. If both solenoids are activated at the same time, the DCV will stay where it is and nothing will happen, right? So we need a difference in strength here. I will also do the following right now. to make it more visual, that we actually do not have the difference here because this is a double acting cylinder, this is a single acting cylinder. We have really in logics, the difference is only there because we have a single solenoid DCV here and a double solenoid DCV. This is called an impulse or a pulse DCV, which means if we activate this solenoid, this chamber will be active, or this switching position. If we activate this solenoid, this switching position will be active. Here it is a little bit different. If we activate this solenoid, this switching position will be active, and if we deactivate this solenoid, this switching position will be activated because of the return spring. That's the difference here. It's not because there's a double acting cylinder, it's a single acting cylinder, it's really because of the DCVs. So I could also switch those. Right? I could also make a double acting solenoid or an impulse DCV here and a return spring DCV here. Right? So the behavior is now really just because of the DCV actuation. So I'll just keep them like this. Doesn't matter. That really does not matter at all. Let me pump that up to 6 bar again. That's good. And let me make some space here so we can actually see some stuff on the screen. So we want to create now very quick a very simple circuit, simple electrical circuit, and therefore I will take the IEC symbol. Sorry if you are from the US and take the NEMA symbols. I'll take the IEC because I am from Europe or the rest of the world, whatever you want to call it. What we want to have first, in this video, in another video I will get more into detail, I want to evaluate the state of those two, right? So I need sensors, I need more actuating labels. I want 1M1 from 0 to 5, and I want 1M2 from 45 to 50. Right.
So class, please understand this. Now what we are going to do is we are going to change the circuit or change the algorithm of controlling it through of controlling it pneumatically to and converting it to controlling it through sensors. Okay. Now what he is doing in this particular practice is, what he is trying to do is he is trying to position your circuit sensors. Okay. So from 0 to 5 there will be 1M1 sensor, and from a 45 to 50 say there will be your 1M2 sensor. That means that 1M1 will be activated when your spool or piston is going to be in the position of 0 to 5. So this across this length of 50 mm, you can see that the length is 50 mm, this range is 50 mm. So from 0 to 5, 1M1 is going to get activated, and from 45 to 50, your say 1M2 is going to be activated. So for the retracted position, 1M1 is going to be activated, and for the extended position, your 1M2 is going to be activated. Understood? And where are other people? There were 21 people at first stage, and now there are only 19 students. Is there some internet issue? 2 students are on this. It is important to focus on this particular concept, that how your sensors are positioned and what is the you can say methodology to position your sensors, and how to integrate your sensor into a particular sequence. Every process has a particular sequence, and in order to confirm that the sequence is going to happen, you need sensors for this. Okay, so the positioning is a matter of concern, and also how to integrate it also a matter of concern. So this is dealing with the positioning.
45 to 50. Right. On this one, I want 2M1. Why doesn't it activate automatically? 2M1 from 0 to 10. And you can already see a little bit of a difference. This one goes from 0 to 100. I could also change the range, but let's stick with it. 2M2 goes from 90 to 100. I'm sorry that I do this all the time, but my nose is really itchy. There was something, like someone is probably putting pepper in the air here. Sorry for that. I'm really sorry. So now I've got those sensors here, and I can also take them actually and put them there, which would change the sensor type, but let's keep them up here because I don't want to go into detail there. So those are things that we can electrically evaluate to see what's going on. And those solenoids are components that I can activate with electricity. So I will give them, oh, this is actually not 1M1. Sorry, this is, I did that wrong in the first video as well. This is actually by standard 1B1 and 1B2. B as in electrical sensor. And this is 2B1 and 2B2. I did that wrong from the beginning also for the other video, so sorry for that. This is the standard to go with. If those are electrical sensors right now, and if there would be mechanical sensors here, I would call them 1S1 and 2S2 and 2S1. There we go. Now I've got it. And those are now mechanical sensors. But I want them all for now to keep it. They should all be electrical sensors. And also still itchy. Because we want to create this electrical circuit. For the solenoids here, I have to give them also names, and M as the description for a solenoid, 1M1, 1M2, and 2M1. There we go. This is, sorry, I should probably use I don't have any paper tissues here. Sorry for that. You have to go through it. You have to go through this with me. Same as with the music. I apologize for nothing. No, I'm sorry. Now that I have my sensors up here that I want to evaluate, and I have my actuators down here, or my control elements down here, not actuators, those are control elements, those are actuators. I need to put them into electric circuit. And I can put them in my electric circuit. Of course, every electric circuit, the first thing you always need is some type of power source. I hope this is still, no. Let's not do this. Let's do this and do this.
Now just we are going to integrate, okay? We are going to have the integration of your electric circuit along with the pneumatic circuit. So just have a brief look at this.
And I cannot make this any smaller or so. I'm sorry for that. That's what we have. So in my electric circuit down here, in my electric circuit, I could simply build a short circuit. That doesn't make much sense. I want to put my sensors and my actuators, not my actuators, but control elements. So as for the sensors, I can search for the correct sensor here. Most versions do not support many different sensors, so but all of them actually support the magnetic proximity switch. And that's what we have here. Those are magnetic proximity switches. I have 1 and 2 and 3 and 4. Right? 1B1, 1B2. I also have to give them the name. As identification, that's what you want to search for, 1B1. You can see as soon as I call this one 1B1, you can see a little arrow. This little arrow indicates as this one here on top is activated. So this one is activated, meaning this one will also be activated. If I now add, 1B2, you will not see an arrow, right? They are linked, those are linked, but you cannot see an arrow because it's not active right now. 2B1, you will have an arrow again. As you can see, 2B2 won't. Right? And if I think I can run the simulation now, if I change the position, you can see the arrows indicating which sensor is active. Right? That's good. This means we are doing something right. Perfect. Since those are electric sensors need, of course, a power source in whatever shape. In our case, it's the 24 volts here. We connect this, 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 we connect this. Whew, that's a lot of connection going on here. And the last thing we need, those we want to evaluate later on. We want to somehow evaluate them, right? And we need, for evaluation, we need to put them into inputs for a PLC or inputs for ports for a microcontroller, stuff like this. In our case, we want to build up some relay controlled circuit. So I will put a relay. And those are our elements. Relays have 24 volts here. We connect this, we connect this, we connect a relay for you and a relay for you. And those are our elements. Relays have contact.
I think the images are a little bit blurred at this moment. Yeah, it is. Let me just refresh it. It is 9:27. So let us just start with a very quick questionnaire at this moment. What are we doing now is 1B1, 1B2, 2B1, 2B2 are your sensors. Okay. Now they are going to sense a particular position of your cylinders. Okay. Now I have a question to you that how are we going to connect this 1M1 with 1B1? How are we going to connect it? See, your 1B1 is your actuation, or it is your sense, or you can say information, or your energy. Can you tell me? 1B1 is going to give information, or it is going to give energy? Information. Okay. So for a particular system, your 1B1 is going to give you a information. Okay. And now this 1B1 is going to energize this particular coil 1M1. Okay. It is very important for you to understand that 1B1 sensor, from 1B1 sensor, there will be a particular logic through PLC, and that logic is going to energize 1M1, and it is going to energize through. So PLC can the power from PLC directly energize a solenoid 1M1, or we need another system for that? We need relays for that. We need relays for that. Am I correct or not? We need relays. Yes. So we are going to connect them through relays also. Okay. So just have a very quick view that how it is connected, because it is very important. And if there is a video issue, let me just refresh it. We will start it from 9:27 only. Okay. I don't want the quality to be compromised.
So welcome back. I already put on our learning music here.
9:27. I will start from this part.
Electric sensors need, of course, a power source in whatever shape. In our case, it's the 24 volts here. We connect this, we connect this, we connect this, we connect this, we connect this. Whew, that's a lot of connection going on here. And we need those we want to evaluate later on. We want to somehow evaluate them, right? And we need, for evaluation, we need to put them into inputs for a PLC or inputs for ports for a microcontroller, stuff like this. In our case, we want to build up some relay controlled circuit. So I will put a relay in here as a relay control circuit, right? A relay for you, a relay for you. you, a relay for you, and a relay for you. And those are our elements. Relays have contacts on them. With those contacts, we can actually see, we can use those contacts in other places and use them as normally open, normally closed, timer, and so on. So I can evaluate this at a later point in time and build an and/or circuit, a hardwired logic. We also have to give those names for later. And this will be K1 and K2. And you guessed right, K3, very good. And K4. Those are now our output elements, right? Those are our output elements. And I want to now also, those are our input, sorry for that. Those are our input elements here in the logic circuit. This I could also call input 1, input 2, input 3, input 4. What we also need are so-called valve solenoids, right? Valve solenoids, this is exactly this thing here. You can see they're a little bit different. I mean, this symbol is the same as this. And this little component you see here is actually a representation of the DC body, right? So this is this, a representation of the DC body. So we will also need 3 of those. Let's give them names. You guessed it, 1 and 1. Oops, I can't hit enter on this. 1 and 2. And 2 and 1. Right? So those are those. And for those I will, let's not zoom out. I won't need this for now, so let's put that to the side. So those are our output elements. I will create a second. I will create a second power source, which I actually don't need, but I'll just put that here. And of course, put those in here. Right, I will put those in here. 1, 2, 3. And now, before them, this is the logic. Actually, we want them to activate. So 1 and 1, let's consider 1 and 1. So the first cylinder here should extend if we press a push button, and as long as we press a push button. I do not have a push button yet, so I will need to add it. I will need to add this to my inputs here. So give me push buttons. There is actually something called switches, manually operated. There is a push button. This push button I want to, here we go. I want to add, and of course it needs another input element, another relay, K5, the so-called K5. And if I want to evaluate, I'll give that a name. This one is called start. Still can't hit enter. This is called start. So I want to evaluate start. Start is connected to K5. So I will need K5 in here. So I will need K5 with a so-called general switch, a make switch. Make switch, if I give this now the name, I can actually select it from a drop-down here, K5. Right? If K5 gets activated, let's see. We have our logic circuit there. I can see a little current flowing and so on. It doesn't matter. Let's only concentrate on, you can see that. Of course, because my face was in the way. Let me push my face up here where it doesn't annoy anyone. So now I can see my, no, it's still the noise. Here we go. where won't I disturb? Okay, I'll just stay up there. If I press the start button, you can see it's connected. If I press start, K5 will activate. If K5 activates, this contact will close. Right? They're directly connected. If this one here closes, 1 and 1 will activate. See that? 1 and 1 activates. And if 1 and 1 activates, what will happen here on the left? You see it? We can't really see it right now. We can see it. If 1 and 1 activates, you see, this changes over, this extends, and now we have a problem. We cannot return anymore. Right? We cannot return anymore. Doesn't matter what I'm doing, I can't return. Right? This is rather stupid. That's why we need some other logic here. Some other logic as, let me take that, actually, then I can minimize this, and now my face won't be in the way anymore. That's good. Let's think about it. K5. K5 is our start button. Activate, this extends, right? As soon as 1v1 is active, I want this to activate. So I will take, like, 1v1 is 1v2. 1v2 is connected to K2. As soon as K2 is activated, right? As soon as K2 is activated, I want 2m1 to activate. So I want this one to activate. Here we go. Perfect. And now I want 1m2, this one, for returning. So right now what we have, oh, my face is still here in the way. Sorry for that. Still, I keep forgetting because it's already late in the night. That's why I apologize, I just keep forgetting. So I have now K2 here, right? K2 is connected to 1v1. So if I press the start button, as soon as 1v1 got active, right? As soon as 1v2 got active, K2 got activated, our contact closed, and 2m1 got active. Let's see. Let's look at it again. There's actually one thing: simulate until next state change. So I press the start button. K5 will activate. K5 will activate, closing the contact, activating 1m1, activating 1m1, extending the cylinder. So that's the first thing that will happen, right? K5 active. Oops, I need to keep, no, I don't need to keep pressed. K5 is closed, 1m1 is active, 1m1 is active, cylinder extends, right? That's the first thing. The next thing that will happen is 1b2 here on top. 1b2 will activate, 1b2 will activate, K2 will activate, K2 will close the contact here, will activate 2m1, 2m1 will activate here, turn over the DCV, will extend the cylinder. So let's see if this will happen. Yeah, next state. 1v2 activated, 1v2 is now active, as we can see here. Activating K2, K2 is now active, activating 2m1, 2m1, that's the next thing that will activate, change over here, changed over, now our cylinder will extend. Yeah, a lot of things in between, and then in the end, we'll activate 2b2. Next thing that I want to do, as soon as 2b2 is activated, I want 1m to activate, and we want to retract. So I want this.
So class, my question to you is, my question to you all is that now what I want is that you understood the process, right? That once it reached to 1v2, once we start a button through this, your K5 is activated, and once K5 is activated, your 1M will be activated. Okay, so once your 1M1 is activated, 1M1 is here. Once your 1M1 is activated, okay, what will happen? This is going to switch. This supply is going to move, and this cylinder, single acting cylinder, is going to extract. When it is extracting, it will reach to, from 1v1, it will reach to 1v2 position. Once it reaches 1v2 position, then your K2 coil is going to get activated. Okay, your K2 coil is going to get activated, your 2M1 is going to get activated. Now what will happen? This will again start to extend, and it will reach the 2v2 position. Now what he wants is, once it reaches 2v2, this particular cylinder start retracting. Okay, so here which number of coil you need to add? So the logic is, once this reaches 2v2, okay, this cylinder should retract. Okay, and in order to retract this cylinder, this coil is to be activated. And how are you going to activate this coil? With which kind of relay you are going to activate? My question is this: whether it will be K5, K4. Yes, it will be K4. Yes, it will be K4. Okay, for this particular logic, it will be K4, correct.
सर
Yes.
सर ये
Uh,
रिले और सोलेनॉइड का कनेक्शन नहीं समझ में आया सर।
अच्छा मैं बता देता हूँ। देखो हमने रिले और सोलेनॉइड को एक अलग तरीके से करेंगे। देखो क्या है कि सेंसर अभी क्या है, आप यहाँ पे अगर देखो तो ये केवल क्या कर रहा है, एक फॉर एग्जांपल से 24 वोल्ट दे रहा है केवल एक रिले को, ठीक है ना। ये एक रिले है जिसका फॉर एग्जांपल यहाँ पे तो K1 है, आप इसको देखो तो ये K2 रिले को केवल एक सप्लाई दे रहा है, केवल K2 रिले को एक्टिवेट कर रहा है, ठीक है ना।
यस सर।
अब जब K2 रिले एक्टिवेट होगी तो ये वाला सर्किट जो है वो कंप्लीट हो जाएगा, क्योंकि K2 पे अब आपको क्या होगा, ये वाला जो स्विच है ये क्लोज फॉर्म में कब आएगा, जब K2 एक्टिवेट होगा, ठीक है ना। तो इस वाले सर्किट में क्या होगा, इस वाले सर्किट में केवल ये होगा कि अगर 1B2 एक्टिवेट हुआ, ये इस पोजीशन पे आया, ये जो आपका पिस्टन है शुभम, जब ये 1B2 पे आएगा तो ये क्या करेगा, ये एक्टिवेट कर देगा इस सेंसर को। ये सेंसर मान लीजिए पीएनपी टाइप का ही सेंसर है, क्योंकि यहाँ से आपको एक पॉजिटिव ही मिल रहा होगा, हो सकता है। या फिर आप किस मान लीजिए एनपीएन भी हो, लेकिन एक सप्लाई जो है वो इसको कनेक्ट कर देगी और ये जो रिले है आपकी ये एक्टिवेट हो जाएगी। ये रिले क्या कर रही है, ये रिले इस सर्किट को क्लोज कर रही है, ठीक है ना।
सर यस सर। हेलो
I think there was a network issue. Class, am I audible now? Yes, there was a network issue, I think. Just a minute, let me look into the network. Just wait for a minute. I think there is some kind of network issue. Yeah, class, am I audible and is the screen presented? Kindly confirm on the chat box. Yeah. Sorry for the interruption. There might have been a network glitch, and due to that technical glitch, there was a network issue. So शुभम, बेटा देखो यहाँ पे हम क्या सेंसर से डायरेक्टली किसी कॉइल को एक्टिवेट कर सकते हैं? मेरा केवल शुभम से नहीं, पूरी क्लास से क्वेश्चन है। नहीं कर सकते ना, तो हमको क्या करना पड़ेगा, एक रिले लगानी पड़ेगी, ठीक है ना। और वो रिले क्या करेगी, एक स्विच को ऑपरेट करेगी, ठीक है ना। तो आप अगर यहाँ पे देखो 1B2 जैसे
सर ये जो सोलेनॉइड वाली सर्किट है,
ये वाली 1M1 वाली ना,
यस सर, क्या ये रिले से कनेक्ट होती है क्या? मतलब
ये देखो ये यहाँ पे एक स्विच है, K2 का स्विच है जो इस सर्किट को पूरा करेगा, और इस सर्किट से जो पास होगा करंट वो 2M1 आपकी कॉइल को एक्टिवेट करेगा, ठीक है ना। तो ये जो K2 है ये इससे कनेक्टेड नहीं है, ये इस सर्किट से कनेक्टेड है, इस सर्किट के लूप को कंप्लीट करेगा, एक स्विच से कनेक्टेड है ये K2 रिले, ठीक है, सीधे सोलेनॉइड से कनेक्टेड नहीं है, एक स्विच से कनेक्टेड है, और वो जो स्विच है आपका, वो स्विच एक लूप बना रहा है, और वो जो लूप है वो 2m1 कॉइल से कनेक्टेड है। ठीक है ना, मतलब क्या हुआ, K2 जब भी एक्टिवेट होगा, जैसे ही 1v2 एक्टिवेट होगा, K2 को एक्टिवेट कर देगा, K2 जैसे ही एक्टिवेट होगा, ये स्विच क्लोज हो जाएगा, और यहां से आपका लूप सर्किट जो है कंप्लीट हो जाएगा। जैसे ही कंप्लीट हो गया, 2m1 पे करंट पास होने लग गया, आपकी कॉइल एक्टिवेट, मतलब सेंसर से रिले, रिले से स्विच क्लोज, स्विच क्लोज होने से आपकी कॉइल एक्टिवेटेड, कॉइल एक्टिवेट होने से आपका डीसीवी चेंज, डीसीवी चेंज होने से आपकी एयर पास होने लगी और आपका एक्चुएशन। ठीक है शुभम?
सर ये जो सप्लाई है 24 वोल्ट का, ये दोनों
हाँ।
सेम है कि अलग अलग है?
ये दोनों अलग है बेटा, ये एक अलग सप्लाई में जा रहा है, ये एक अलग सप्लाई में जा रहा है। कई बार हम किसी सर्किट में सेम लाइन पे अटैच कर देते हैं इसको, हम इसको आगे ही फॉलो करके अटैच भी कर सकते हैं सेम सर्किट लाइन पे, लेकिन ये इस कॉन्टेक्स्ट में नहीं है कि 1v1 के साथ ये सीधे डायरेक्ट करंट पास कर रहा है। ठीक है ना, ये सर्किट हमारा सेम भी हो सकता है, चेंज भी हो सकता है। कई बार क्या होता है, हम एक कॉमन लाइन ले लेते हैं 24 वोल्ट की, उस पर ये भी कनेक्ट कर देते हैं, ये भी कनेक्ट कर देते हैं, और हम अपने रिलेज के कॉन्टेक्ट को भी कनेक्ट कर सकते हैं, केवल स्विचिंग के लिए तो चाहिए। ठीक है ना?
सर फिर जो ये 1v2 सेंसर से जो आएगा सिग्नल, वो कितने वोल्ट का होगा फिर?
हाँ देखो, ये भी आपका जो 1v2 से आएगा, वो हमारा सिग्नल 24 वोल्ट को रिप्रेजेंट तो कर रहा होगा, एक्टिवेशन तो 24 वोल्ट के आसपास का होगा, लेकिन क्या वो वोल्ट 24 वोल्ट का जो है वो इतना एम्परेज दे पाएगा जिससे कि आपकी कॉइल एक्टिवेट हो जाए? ये बताओ बेटा।
बट सर यहाँ पे 24 वोल्ट का ही तो सप्लाई जा रहा है इसमें।
बेटा हाँ, फिर वही बात, 24 वोल्ट का सप्लाई जा रहा है, लेकिन एक एम्पेयर नाम की चीज होती है ना,
यस सर।
है ना, होती है ना। तो
Yes, sir.
ये जो 24 वोल्ट का तो सप्लाई देगा, चलो ठीक है, आपकी K2 के बीच में 24 वोल्ट आ गया, लेकिन क्या वो एम्पेयर मिल पाएगा इसको?
ये सर करंट नहीं प्रोवाइड करेगा।
क्या वो पावर मिल पाएगी इसको जो कि एक कॉइल को एक्टिवेट कर दे? आप खुद सोचो, क्या एक सेंसर 24 वोल्ट तो दे रहा है, इट इज कैपेबल ऑफ प्रोवाइडिंग अस 24 वोल्ट, बट is it capable to provide that amperage, or not even amperage, you say that power, because volt into current will be your power? क्या वो इतनी पावर दे सकता है कि क्या वो इस कॉइल को एक्टिवेट कर पाए?
नो सर।
नहीं कर सकता ना, उसके लिए हमको एक रिले लेके एक अलग से सर्किट बना करके उसको लूप में लगाना पड़ेगा, हमें है ना। तो जब हम, इसीलिए उस रिले की जरूरत पड़ी। 24 वोल्ट इज नॉट द इशू, ठीक है ना, पावर वॉज द इशू।
ओके।
ठीक है ना, 24 का हेड तो मिल सकता है, लेकिन फ्लो भी तो कम मिल रहा है फिर। ठीक है ना, वो तो दैट इज द इशू। अब समझ में आया? सबको समझ में आया? किसी को कोई डाउट है क्लास?
यस।
या सो दिस क्वेश्चन इज ओपन फॉर ऑल। आर यू अलाइन्ड टू दिस? हैव यू अंडरस्टूड दिस? या कोई डाउट है अभी? Is there any doubt class? Yes or no? No. Okay. Okay, let us just complete this and we'll have a break then.
One and two activate, and we want to recheck. So I want, this is now actually not too complicated. Whoops. This should be easy. This should be easy. This should be so easy. As soon as 2v2 is connected to K4, K4 should activate 2m1, and we will have this whole sequence. Right? Was K2, K4. My bad. K4. So let's see. I press the button, cylinder 1 will extend, cylinder 2 will expand. As soon as cylinder 2 is extended, both will retract. Here we go. simple electropneumatic circuit. This can get more complex, of course, but I think spending already almost 20 minutes on this is a good job. So here we go, right? Done that. So far, so good. We have our pneumatic circuit, we have our inputs definitely, and we have our outputs. What we will do in the next video is actually looking at this and making this a little bit more attractive, right? This is because this is right now not very adaptive. This is just a very simple circuit, so we move our components.
So in the next video, we will look at the improvisation that can be done to the relay contact. Okay, so shall we take a break now? Okay, we'll take a break and then we'll meet at